Good morning, students. So today we are going to start our chapter 6. In chapter 6 you have your chapter name is application of derivatives. That means already in chapter 5 and as well as in class 11 you have learned about derivatives. Now what are the different uses of derivatives? So today we are going to learn. So the topic that is given in the first from this chapter is rate of change of quantities. So as you can see here, I have written 6 different style of derivatives, isn't it? Now S is a function where I am differentiating the function with respect to what? T. In Y we are differentiating the function with respect to T here, and in X variable function we are differentiating with respect to T. Again in the next is I am writing ds by dr. That means I am differentiating this function with respect to r, y function again with respect to r, and x with respect to r. So here rate of change of quantity. So what does rate of change means? Differentiating a given function with respect to time or with respect to radius. This type of functions are known as what? Rate of change of quantity. That means you are differentiating the function either with respect with time, or you can change with respect to radius, or you may have different other quantities also. For example, suppose you have a question here, find the rate of change of area with respect to radius. Now already it is given, you have to change the area of the circle with respect to the radius. That means your function is the area of the circle and you have to differentiate with respect to the radius, where the radius is given to 5 centimeter. So how you are going to proceed for this type of question is, first you have to know what is the area of a circle. That is, we know that area of a circle is pi r square. So you have to now differentiate with respect to radius. That means you have to differentiate the area quantity with respect to radius. So as we all know that pi is always a constant number, so we can write, so after differentiating we are getting twice pi r. Now this is the quantity that is changed, but you are asked to find the value when the radius is 5 centimeters. So how you will do? Simply you have to differentiate the function and you have to use a dash or slash, and you have to write here r, that is equal to 5. That means after differentiating the function you have to put the value. So what is the answer? 10 pi square units, or you can write 20 pi centimeter square. So this is the answer of how to do the rate of change and to put the value per centimeter square per centimeter. Why? Because area is centimeter square and you are changing the rate with respect to radius, so it is in denominator, so the unit will be 10 pi centimeter square by centimeter. Okay. Next question, you can see here, the length x of a rectangle is decreasing at the rate of 3 centimeter per minute. That means your rate of change of the length is with respect to what now? Time. So by looking at this I can write here dx by dt equal to minus 3. Why? Because it is decreasing, okay, and the width is increasing, that is dy by dt should be equal to 2 centimeter, or no need to write, simply you can write 2. Now what is the question here? When your x value is 10 and y value is 10, find the rate of change of the parameter. So already we know that parameter is always 2 times of x plus y. That means you have to differentiate the parameter with respect to what? Time. That means 2 is constant, so I can write dx by dt plus dy by dt. Simply 2 we will write, dx by dt is already given minus 3 plus 2, so the answer will be minus 2 centimeter per minute. So there is no use of x and y here for this parameter, so we are not using the value. So dx by dt is given as minus 3, dy by dt is given as 2, so simply we have put the value over here. Next is what will be the change in area. So as we all know that area is length into breadth, isn't it? So again we have to differentiate with respect to time. So when we will differentiate with respect to time, we have to follow our product rule, that is x dy by dt plus y dx by dt. Now x value you have to put 10, dy by dt was 2, y is also 10, but dx by dt is minus 3. So 20 minus 30, that is minus 10 centimeter square per minute. Okay, so I hope by looking at these two examples you are now able to understand what is the application of derivatives in these two sums. Okay, so I am picking my first question of my exercise. There are two questions, so I shall be taking the first part. So in this question it is given, find the rate of change of area of circle with respect to the radius when your r is 3 centimeters. So as we know that area is pi r square, so you have to differentiate with respect to r. So d dr of r square, so d dr of r square is twice r. So dA by dt you have to find it for when r is 3 centimeter, that is 2 into 3. So the answer is 6 pi. Area is centimeter square per centimeter, isn't it? So this is the answer of your question number 1. Okay, next let us go for question number 2. So what is given in question number 2? The volume of the cube is increasing at the rate of 8 centimeter cube per second. So dV by dt of cube is given as how much? 8 centimeter cube per second. How fast is the surface area will be increasing? So you are asked to find the rate of change of the surface area when the length of the h is given as 12 centimeter. Okay, so this is the information given to you all. So now let us see. So you must know, so since I am taking my h to be 12 centimeter L, so we know that what is the formula of volume of a cube? L cube, isn't it? So L cube will be 3L square dl by dt. Okay, so this much we have to do it. So when we are differentiating L cube, so you have to differentiate with respect to t, but since we have to do the first differentiation, normal differentiation, then we have to write dl by dt. Okay, so in this question L cube means the volume is already given, this part is already given. So this part is given as how much? 8. Okay, so let us write here. So already this is given 8. 3 into L square, L is already given 12 square, but we don't know the value of dl by dt, isn't it? So we have to keep it as it is. So dl by dt will be 8 divided by 3 into 12 square. So let me keep the value for the time being this way. Okay, now your question is to find the rate of change of surface area. So we must know what is the formula of surface area of square is cube is 6L square. So ds by dt equal to 6 is constant, ddt of L square. So ddt of L square will be twice L dl by dt, isn't it? So 6 into 2, so L value is already given as 12, and dl by dt, just now we have found dl by dt is this. So 8 divided by 3 into 12 into 12. So 12 and 12 will be cancelled. 6 into 2 is 12. This is also cancelled. So the rate of change of the surface area of the cube will be this. Okay. So in this way we can do the sums using the application of derivatives. So I hope all of you got the idea of this chapter. Thank you.